Bismillahirrahmanirrahim. Assalamu alaikum to students. Welcome back in lecture 02 part 4. Student, as in lecture part 02 part 3, we discuss the maximum spacing between the bars, S max. Remember the spacing S max which we discussed in previous lecture. These spacing, these limitations are applicable same as in slab, right? Now in this lecture, in today's lecture, we will discuss the minimum width of the beam. This is important, that what should be the minimum width of the beam. We will discuss depth in later lecture, but first we will discuss this topic. Now in this lecture you will see how we can find out the beam minimum. This is one of the most important question because there are some certain ACI criteria that whenever we are placing the bars, as you see here in this figure, so there must be some certain spacing, like you can see here. We will discuss that spacing, but in previous lecture we discussed the S max, that how much these bars should be placed, what should be the maximum distance. Now there are some certain criteria where it explains that there should be S minimum. We have to make sure that S minimum, and we have not to put these bars in close manner, because this creates some kind of bond issues, and we will discuss them in later lecture. But at this time, that why this kind of discussion is very important, because on the basis of these criteria we find out the B minimum, right? This is important, and that's why ACI code specify that we have to ensure 2 diameter of bar 2 dB and 3 times 3 diameter of bar. On this criteria they find out some certain depths. They lay down some charts for on this condition and this condition, because on this spacing the development length LD depends. I have recorded so many lectures, around about 18 lectures on development length, so please go there and watch the development length equation. I have proved it. So in that development length, basically it depends on this spacing, which is right here, this one. We will discuss this in coming lecture, but you must know why there should be a minimum depth. What is the importance of minimum depth? This is important, right? You must know that we have to maintain this minimum depth, right? To place the bars with some certain specific spacing to create the full bond strength. We have already discussed the side cover. What should be the minimum side cover? We discussed this in part 1. Similarly, bottom cover, we will discuss the importance in coming lecture, that what is the importance of these kind of spacing and cover. Now the question is this: how to find out B minimum? We will handle this question in this lecture. So you can see here, this is a beam section, right? And here we can see this is stirrup. This is my stirrup. Now here we can see whenever we are placing a very small bar less than 11 dB, small bar, whenever it is 11 number less than number 11, so there is a space, right? You see here, because the bend is wide, the bend of this stirrup is wide and the bar dia is small, so they cannot be completely fixed with the stirrup leg. So there is a kind of gap, and that gap is denoted by C. and the diameter of the bar is denoted by B, and the side clear cover is denoted by A, while the diameter of the bar is denoted by dB, right? And the spacing between these two bars is denoted by S. Now on the basis of this criteria, the minimum width B minimum, we can find out the B minimum. It should be equals to these two side cover, one this A, one that one. So we have A, then we have B, then we have B, then we have C. It should be multiplied by 2 because we have this side as well, plus we have bars, so that why here we have 2 bars, but let's say we have in bar, so in times diameter of the bar, then plus the spacing amongst the bar. So as we see here, we have 2 bars, so we have 1 spacing. If let's say we are using 4 number of bars, so in 4 number of bars we have 1, 2 and 3 spacing, means the spacing is a function of number of bars, that is n minus 1, right? So let's say if we have 5 bars, so 5 minus 1, the spacing will be 4. So this is the equation for the way at which we will determine the number of spacing. So here we write down n minus 1 into S. This formula will find out the minimum width, and if sometime, as we discuss in part 3, that how we from this equation we will determine the S as well, right? So how to determine S? That is the spacing among the parts, because sometimes we need the spacing. So it can be determined by B, the width of the beam, minus 2 times A plus B plus C plus minus n times diameter of the bar divided by n minus 1. This will find out the spacing amongst the bar, and this spacing is important because we have to compare the spacing is that whether the spacing is greater than S minimum and whether the spacing is less than S max. So that's why the spacing is very important to find out the spacing, and we will do this calculation in our example. We will find out sometime the minimum beam width and sometime the maximum beam width, and we will compare the spacing. Now the question is this, that what is the value of C? The question is this, because A is clear, we will calculate it is 1.5 inches, which is minimum ACI code criteria. B is fixed, this is number 3, number 4, number 5 bar. C is in question. What will be the value of this C? Because DB is clear, S is clear. Now there are some certain cases for C. Note down here that C will be equals to 0.75 minus diameter of the bar divided by 3 for number 11 and smaller bar. While in some cases C will be equals to 0.75 times the diameter of the bar. We can use either this equation or we can use either this equation. This is the case when we have this number 11 and smaller bar. When this is case 1, this is case 2. When we have number 14 means the diameter of the bar is greater than number 11. So now we have two bars, alright? We have two bars only in this case, that is number 14 and number 18. So in this case, some research says that it is equals to 0, C equals to 0, but some says that C will be equals to 0.5 times of the diameter of the bar, right? So this calculation will be used right here, and let me discuss this chart right here. This chart is basically drawn on the ACI code minimum beam width. As you see here in inches, what should be the minimum beam width when we are placing, remember, single layer of reinforcement? If the beam is fixed, let's say it is defined that B will be 12 inches, and we will use the check that the beam minimum is, this beam is less than beam minimum, and we have to increase the B value. Now in that case, we will provide the steel bars in double layers or in triple layers. So here you can see here number of bars in single layer. So if we have single layer of bars, for this is my bar designation. That is for if you are placing, let's say, number 4 bar in a beam in one layer. Let's say we have in one layer we have 2 bars. The minimum beam width will be 6.8 inch. Similarly, if we are placing 3 bars in one layer, the minimum width will be 8.5 inch, 8.3 inch for number 4. Similarly, for 4 this dip, for 5 this, for 6 this. If let's say for 8, so if you are placing 8 number 4 bar in one layer in a beam width, we have to provide 15.8 inch the beam width. But noting down here, if we are placing more than 8, then we have to add 1.50 for each bar. Let's say for 9, so for 9 we will add 1.50 with 15.8. So let's say we are using 9 numbers of bar, so the beam minimum will be 15.8 plus 1.5. But if let's say we are using 10 bars, no, for 10 bars, let's say someone using 10 bars, number 4 10 bars in one layer. In that case, beam minimum will be 15.8 plus 1.5 times of 2, because 10 bars, for 8 bar we have to provide this width, so we have to add 1.5 for each bar, means we have 2 bars now. In between 10 and 8 we have 2 bar difference, so that's why we have 2 bars, so that's why we will multiply 2 with 1.50. This is the reason. Similarly, for all the beams, for all the bars, you will see the minimum beam width, and we must ensure this beam width, right? Here you can see table shows minimum beam width when number 3 stirrups are used. For additional bars, add dimension in last column. For bars of different size, determine from table the beam width for smaller size bars and then add last column figure for each larger bar. Assume maximum aggregate size does not exceed 3/4 of the clear spacing between bars. This is important. The statement is important, and it says that the beam width is fixed, that it is here assumed that the aggregate size will not exceed 3/4 of the clear spacing, right? Similarly, 3 3/4 of the clear spacing. 3/4 means the aggregate size of aggregate, it should not be greater than, it should not be more than the 3/4 of the spacing. Mean that yes, it should not increase. Assume maximum aggregate size does not exceed 3/4 of the clear spacing. And similarly, you can see here this figure, and I have already discussed A will be equals to 1.5 inch, B will be equal to 3/8 inch, and C for number 11 and smaller bars use twice the diameter of number 3 bar are equals to 0.75 inches. 0.75 inches. For number 14 and number 18 bars, you see equals to 0.5 diameter of the bar. So for number 11 and smaller bars, number 11 and smaller bar, use twice the diameter of number 3 stirrup, right? 2 times of diameter of stirrup, that is C equals to 0.75 inches, means we are using number 3 stirrup. So number 3 stirrup diameter of the bar is 0.375. So in this case, the diameter of the bar 2 times will be 0.375. It equals to 0.75 inches. So C will be equals to 0.75 inches. R, it can be determined by using this equation, that is 0.75 minus diameter of the bar divided by 3. R C will be equals to, this is C, R C will be equals to 2 times the diameter of the bar of stirrup, right? So this is the discussion that we have to understand, that how to find out the minimum diameter beam breadth. Similarly, we can see here 2 times of diameter of bar and 3 times of diameter of bar. On the basis of this, we can see the minimum width of the beam, right? Similarly, the same designation right here, and the minimum width, as you can see here, and side cover will be 1.5 inch, number 3 stirrup for bars number 11 and smaller, number 4 stirrups for bar number 14. In this, since stirrups are bent around 4 stirrup bar diameter, the distance from centroid of the bar nearest side face of the beam of number 3 stirrup is taken as 0.75 for number 11 and smaller, and equal to be the radius for number 14 and number 18 bars. This is the value. This basically defines the value of C. But I already write down the equation that C will be determined on 0.75 minus diameter of the bar divided by 3, or it will be taken as 2 times diameter of the bar of the stirrup, right? But this will be used for number 11 and smaller bar, where for number 14 and 18 it may be equals to 0, or it may be equals to 0.5 times of the diameter of the stirrup bar. So next, this table is basically based on 2 diameter of the bar spacing, means the spacing between 2 bar, this one is equals to 2 times the diameter of the bar. This spacing is very important, and we will discuss this in coming lecture, but I have already recorded lectures that is related to the development length of the development length, and so this 2 times of diameter of the bar is important, because when we are changing this, the equation of the development length is changing, and if you are decreasing this spacing, it will causing the increasing of the development length, and then it was difficult for us to adjust the longer development length. So that why you are increasing this spacing, but make sure you have to increase this up to a certain spacing, that is S max. We can't increase the spacing from this value, right? Now here you can see this table. This table is basically, you see here, this is on the one layer bar, one layer up bars, and this is specified on 3 times diameter of the bar, mean that here we are ensuring 3 times diameter of the bar. And the minimum widths are, you can see here, that here you can see number 4. So in the previous case we find out this is 15.8 inch around about, but here you can see this is 17.3 inches. So all this discussion means that we have to make sure a proper spacing for the bars, that we have to ensure a minimum and proper detailing of the bars in any given section. The spacing, this spacing and this kind of detailing is very important to ensure the full bond strength of the because if the full bond strength is not developed, the steel bar will not yield. So for complete yielding, this kind of detailing is very important. See you in next lecture. Thank you for watching.